Then in step 2, on the ribbon, click the Map tab, click Bookmarks and choose Inference Area. You'll use the trained model to classify the buildings in this extent. In step 3, on the ribbon and command search, type classify objects using deep learning. This tool uses a trained model to make classification predictions. The input raster gets split into tiles, which are later fed in batches to the model to classify features. The classifications, after some post processing, are written into a specified output feature class as instructed by you. In step 4, for input raster, choose USAA imagery 11, 13, 18. Next, you'll choose the feature to be classified in this class. In this case, it will be in the unclassified buildings. In step 5, for input features, choose building features. The tool creates an output feature class dataset and you can name it as you want. In step 6, for output classified object feature class, type inference buildings. Now you'll input the model you've trained. For model definition, click browse, open the building classify folder, click the building classify.dlpk deep learning model package file, and then click OK. There is something that you need to be careful of. It's that if you did not train a deep learning model, browse to the projects folder, open provided results, then open buildings classify, and then click with the buildings classify.dlpk deep learning model package file, and then click OK. The next parameter specifies the name of the field in the new layer that stores how each feature will be classified. Then in step 8, for class label field, keep the default value class label, and again you'll set the batch size. Batch size is how much chips, how much splits of chips will be there in a specific in one batch, which is how many sets of image chips are processed at a time. Then step 9, under model arguments for batch size, type 8. Before running the tool, you'll set some environments, and then in step 10, click the environments tab. Under processing extent, set extent to current display extent. After you choose current display extent, the coordinates of the extent's geographic bounding box are displayed. In step 12, under raster analysis for cell size, type 0.3. Then step 13, under process type, set process type to GPU. Click run. This tool can take 30 minutes or more to run depending on your computer's hardware, whether GPU or CPU. If it's GPU, then it will be faster, and if it's CPU, then it will take some time. Note the ability to set the batch size to 8 depends on your GPU. If the tool fails to run, try changing this parameter to 4 or 2. In other words, try decreasing it until it works. The results are added to the map. In step 15, in the content pane, turn off the building features layer and then finally save your project. Then comes reviewing the results. Now that your results have been added to the map, you'll see how accurate they are. To help with this process, you'll change the symbology so that the features are different colors based on their damaged or undamaged classification. This will be done with the provided layer file containing an appropriate symbology. Here are the steps. In step 1, in the content pane, click the inference building layers to select it. In step 2, on the ribbon, click the Paris tab in the drawing group and then click import. The import symbology windows appears. In step 3, for symbology layer, click browse and go to the Woolsey file folder. Select inference buildings symbology.lyrx and click OK. The tool's parameters are automatically populated in the import symbology window, as you can see in the image, and then finally click OK. In step 5, on the ribbon, click the edit tab. In the selection group, click attributes. In step 6, in the attributes pane, if necessary, click the layers tab, choose inference buildings. Click the play button to start cycling through the building footprints. Observe how well your model classified the buildings as damaged or undamaged. If you want to change the classification for a feature, click pause and update the class label as per your requirement or need. In step 8, save your edits, and in step 9, finally save your project. That's all for this lesson. I hope you like it, and it will help you in understanding to automate the process of a fire damage assessment with deep learning. Thank you.